Hello and welcome to the 101 Earth Observation Virtual Lecture Series. This series is delivered by the Satellite Applications Catapult in partnership with WILDLABS. This lecture is about how remote sensing is being used, and we will see a specific application on environmental remote sensing. This application is about the search for lithium in Cornwall. Cornwall is a region in the United Kingdom at the south tip of it, southwest. Before entering into detail of the project itself, let me go through the different steps of a typical remote sensing project. Project means that we start with an idea. So in this case, the idea was like there is potentially, lithium in Cornwall, and how can we use remote sensing data to support the search for it, and alongside it do an environmental study on the region. Once we got the idea, the second part is typically forming a consortium. The consortium is clearly composed by whoever had the idea. That can be an individual, can be a group of individuals for one organization, for more than one organization, but also other partners such as stakeholders. Once the consortium is formed, there is a typical bidding process where basically there is a search for funding. So this sort of project, they do require clearly some funding to get through and to pay the individual work that is done to run the process, and this is through a bidding process. Once the project is awarded, typically there could be end user interviews where the problem is studied a bit more in detail, and a complete understanding it's gained. This brings to the remote sensing part, which is the architecture definition, where the architecture of the project, such as how we use remote sensing data, is defined. This is executed, so the process of remote sensing, the processing of remote sensing data, it's done. Remote sensing and other data. So very, very often, not remote sensing is part of the solution. It's not the complete solution. Validation of the product, and then final product. So this is a typical path. So the idea, so in this case we are talking of lithium. Cornwall, which is again the region at the bottom of the UK, southwest, was an historical mining hub since many years, and lithium has actually been recognized in Cornwall in 1864. At depth. But at the time, the importance of lithium wasn't as now. Now lithium is a very important metal for the energy transition, but not at the moment. And what is important here to stress, it's a bit more on the geology, is that lithium is actually channeled through faults, through geological faults, specifically with a specific direction, and it lies in geothermal brines, which are quite depth, so at the depth of 400 meters or more. So those are like details that are important in developing the project. I don't want to enter so much into the technical detail of the project, but I want to showcase and to stress how a project is formed and how we use remote sensing. So consortium, as I said before. So in this case, this project at the partner that we see over there, and the project is running through different phases. So there is a first phase, which is like a sort of feasibility study, which can be followed by other feasibility potentially in other areas, and an evolution of the projects towards probably the final product. So in this case, I'm describing you the feasibility study. And the feasibility study was around two specific test sites, which are described or which are shown over here, over this region in Cornwall. What we see here is actually the final visualization tool. So that's the final product, where different layers are shown, and it's all in a nice graphical way. This project has been called, well, without much fantasy, Project Lithium. Architecture definition. This is, once we got like an idea, we need to define the architecture of the project. Again, I'm not entering so much into detail here, but let's just see the two final product over there, which is the lithium probability of occurrence map and an environmental baseline study. So those are the two main pillars of this feasibility study. So where basically lithium is probable to occur, and what's the environment over there. To do this, we use as input the imagery and in different packages. Input datasets, in this case, there were several. We will see this in next videos, but from free open access data to commercial data. Commercial data, example here, world view, we see an area here in high resolution. Part of the project was to derive several proxies. Why proxies? Because remote sensing cannot actually detect a geothermal brine directly. That happens at a very depth, like at 400 meters or more. But what can see, it's generally the surface. Now, how geothermal energy is propagated through the surface, there can be some surface components that are proportional actually to this energy. What I mentioned before, lithium is channeled through faults. So another product that we were looking here is to enhance the already available set of faults. In this case, we derived this new set of faults with Earth observation data. Vegetation might be affected by the presence of geothermal energy, and we created some vegetation characteristics, such as the cover map, the land cover here, so with a very detailed classification, and temperature as well. Land surface temperature is something that can be derived with remote sensing data. Combining land cover, combining land surface temperature and other indicators, we were able to derive a map of vegetation anomalies. So why anomaly? Because potentially an anomaly can be associated again to geothermal activities. And this is another proxy, of a potential proxy of the presence of lithium. There are different proxies that I didn't show, but I've shown fault lines, I showed vegetation anomalies. Another direct proxy is called mineral alteration. It's basically how rocks are altered by heat, which is something that is derivable as well with your data. And displacements, so looking, for example, at active faults. No? So when we have a fault, it's possible that the terrain is moving. By combining these with expert knowledge, we were able to create like this sort of concept, which is like from lower probability to higher probability, and getting a map. So the intersection of all the faults, they're clearly something that indicates a higher probability of lithium presence, while if there are no proxies, then we have a low probability. So this is the overall concept of this first phase, which was combining this properly to get an indication of probability with expert knowledge. So with geologists that were looking into it, with botanists. Other phases of the project, which are not shown here, actually used artificial intelligence to properly combine it. But that's something that, I don't want to focus so much on the technique, but again, I want to show you how a project is done. There was a validation done within this feasibility, which meant going on ground and validating fault lines, validating mineral alteration, validating basically all the proxies. This is very important to gain confidence in our product. And the final product, which looks something like that, that's actually a mock-up version. There are different squares here that they relate to the lithium probability. The second part of the study was the environment, and what we see here is the environmental constraint map, so which tells us specifically is a good description of the land, such as areas where there are national parks, areas where they're subject to potential flooding, even areas that they have like invasive plants and so on. By this way, potentially, there are areas that are more subject, for example, to mining activities than others. So this is part of the environmental constraint map. Again, so this was to describe you like the whole project. So rather than focusing on the products, I wanted to showcase how remote sensing data can be used and how a group of people can go together and gather together to deliver products such as this one, which have clearly a high impact.